Hello, everyone. Good morning, good afternoon, good evening, depending on where you're joining us. Welcome back to this series on MI2, which is Machine Intelligence on Modern Infrastructure. This webinar, we have a pretty interesting concept that's coming up, which is all about building and managing ML pipelines. So the title is the nuts and bolts of building and managing machine learning pipelines. And it's my pleasure to have one of the pioneering platform as a service offerings on ML called Gradient by Paperspace. And I have the product team and the co-founders with me to actually walk us through the entire concept of building ML pipeline and also talk to us about ML ops. So if you're attending this for the first time, let me set the context. MI2 is a pretty interesting concept where I talk about the convergence of machine intelligence with modern infrastructure. So every alternate week, I bring one of the tracks. Under the machine intelligence track, I cover cognitive computing, deep learning, neural networks, IoT, edge computing, and AI. Under the modern infrastructure track, I typically cover Kubernetes, serverless computing, infrastructure as code, service mesh, network policies, everything that you expect under the infrastructure umbrella. So this week, of course, we have the machine intelligence track, and it is all about ML pipelines. So after this session, I'm going to upload the video to my YouTube channel, and all of you will receive a follow-up link. So without further ado, I want to hand it off to Daniel, who is one of the co-founders of Paperspace and of course the Gradient machine learning platform as a service. And he's going to introduce us to the platform. And then we also have Misha, who is one of the product managers working on Gradient. So let me turn it over to Dan and Misha. So
awesome. Hey everyone, it's great to be here. My name is Dan, and I'm one of the co-founders of Paperspace, where I head up product and community. Right, so sorry, I just wanted to set the stage for a little bit. Thought it'd be interesting just to spend 2 or 3 minutes before we dive into the demo talking about some of the lessons that we've learned having worked in the trenches of the machine learning industry over the past 5 years or so. So back in 2015, when we first started the company, my co-founder and I were really excited about the future of GPU computing, which is relatively novel at the time. And so the product that we initially launched with was a GPU-enabled virtual machine in the cloud that came preloaded with everything you needed in order to do machine learning or build machine learning models. And we called that ML in a box. And when we initially launched, this product really took off. We had some really nice traction at the beginning. We were signing up over something like 10,000 users a month. And we had this amazing community of people, using cloud computing for the first time and training these really incredible models. And while this is a really exciting phase of the company's life, the more and more time that we actually spent with these users, we began to realize that while our bet on GPUs was correct, the form factor was wrong. And so I guess what we started to realize is that people were spending the vast majority of their time tinkering with drivers and their virtual environment and dependencies, data, and very little of their time was actually spent building these models. So what we decided to do is just take a step back and started thinking about, what would machine learning look like in 2 to 5 years? What does collaboration and versioning look like in the context of ML? How is model serving different than classical web services? So we started to survey some of the best practices that were just starting to emerge, in this really early technology. This is early days of containerization and when Kubernetes was becoming a familiar term for the first time. And so that process led to Gradient, which is a software abstraction layer that sits on top of any infrastructure that really formalizes these best practices into an end-to-end ML platform that makes it quick and easy for anyone to get up and running in a powerful environment that just works. So that goes all the way from concept and R&D through production. So why does this matter? Why is this useful? As I'm sure you know, the way ML is conducted today is really ad hoc. There's very little reproducibility and determinism in the way that the data scientists work, which is really in stark contrast with more mature industries like DevOps and software engineering, where best practices and tooling are more mature. So at a high level, what we decided to do with Gradient is to take the last couple decades of software engineering best practices and apply that to machine learning. And that concept is something we call CI/CD for machine learning. And so that's what we're going to be showcasing today. So I'm actually going to stop there and let Misha kind of take over, and he's going to do a couple slides, run through a couple slides, and then jump right into a deep dive that will kind of show what that looks like in practice.
Sweet, Dan. Thank you so much. So I'm going to go and kind of jump ahead and try not cover any of the same content here, but really at Paperspace, we view the biggest barrier to AI adoption in a really fast velocity for machine learning engineers and constructing production grade machine learning pipelines and systems. It's not necessarily about the algorithms, but it's all about the infrastructure and tooling that surrounds that. There's oftentimes not a lot of best practices, kind of people are going and building it out themselves. There's a really high barrier to go in and productionalize these systems. Kind of how do you go in and convert that research code that you have running locally inside your notebook to something that you can go in and scale out on hundreds of GPUs, version track everything, and then be able to go in and deploy and update these models that are actually going and serving real production traffic. And then also just the ecosystem is moving very, very fast. So how do you always stay up to date and take advantage of all of the best building blocks that are constantly being released by research, academia, etc. And so when we take a look here, this is kind of an end-to-end pipeline that you're all, I'm sure, very familiar with, where you have data coming in and streaming in, being enhanced by some publicly available data. You're kind of going and diving into kind of your exploratory phase of the process. You're trying out your code, making sure it goes and compiles. And then you kind of need to go in and be able to scale out the actual experimentation on these large scale distributed training or batch or hyperparameter jobs, where you're capturing all of the inputs, the data set dependencies, the hyperparameters, the containers, the environment in which you ran, as well as going and tracking and capturing all those model and data artifacts of the training or various pipeline steps. And then being able to go in and quickly take those, evaluate, profile, compile them, and then be able to actually optimize them for inference, and then very quickly go and deploy real gRPC or REST-based endpoints with performance monitoring on how these models are actually doing in production. And so what Gradient does is really kind of makes that whole process really, really easy. And part of that is through that CI/CD approach that Dan mentioned. And we're all familiar with CI/CD for software development. You kind of have code, you push it up to your source control repo, you go and you bundle it up in a container and you automatically deploy that application. With machine learning, there's a little bit more complexity around. You have to have both the data and the code that you're going and bring it in together. Both of those are critically important to being able to reproduce exactly what's going on. There's various types of compute and operations that you want to perform, such as you want to be running it on different cloud environments, whether that's in a public cloud or in an on-prem environment. You want to be doing featurization on a larger CPU instance so you're not getting bottlenecked. And when you're doing training, you want to actually be able to scale up using PyTorch or TensorFlow distributed on tens or hundreds of GPUs without losing a lot of performance. And then when you're going and deploying these models, you kind of want to be deploying them either on specific inference hardware or kind of taking the model and actually making it perform far faster and with some kind of pruning or quantization technique. So the terminology in the way that you chain these things together is very, very different. And so that's kind of where a lot of people end up falling short, and they end up kind of only tackling one of these specific elements, or they end up spending a bunch of time trying to dive in and manage one of the parts. And so what Gradient does, we enable kind of you to go and train these end-to-end machine learning pipelines with a CI/CD Git-driven development workflow, everything from research to large-scale training and experimentation, all the way to going and deploying these models into production. And that's what we're going to kind of be going and showing you today. And so the thing that ties all of this together is called Gradient CI, which is that continuous integration, continuous deployment for these machine learning models and machine learning pipelines, where you really need to be able to get reproducibility, determinism, and the ability to go from research to production really, really quickly. So when we take a look at this, which is a slightly different view of that same slide that we were showing previously, you kind of have the data coming in, various ETL or collection systems, as it's going in and entering into kind of the cloud location where you're going to be going and doing the compute, this is where kind of Gradient CI goes and kicks in. And as you go and you push your code, or kind of you have other triggers that go and occur, you're able to go in and build, train, analyze, and profile and compile these various models, taking advantage of all of these things that allow you to be very productive as there's more and more people that are collaborating together inside your machine learning team, or even me as an individual or you as an individual are trying to train more models and want to be able to look back and see what you trained previously. You can go in and look at the exact specific commit that's tied to a specific experiment that's tied to a model that you've trained and that's now actually going and serving production traffic for, or kind of hosting a web app that you've built. And so Gradient CI allows you to have this really quick development friendly workflow for executing really complex machine learning systems. And you can do that quickly, you can version, collaborate, you can scale it up to any level without really needing to deal with any of that underlying infrastructure. And all of that's kind of tied into that deployment and inference engine. So you can go in and really make sure that you unlock business value for your external customers or internal stakeholders. So I'm going to take a quick step here and just cover Gradient as a whole, because there's a lot of different capabilities inside there. We're really going to be jumping into a demo after this and walking you through that end-to-end development workflow from being inside of your workspace or Jupyter, running, making sure that your code goes and compiles, kind of get your research or prototype thoughts down, and then how you actually go in and scale that out into these end-to-end pipelines and then be able to deploy that with that source control driven workflow and really kind of show you all the different elements of that. But Gradient kind of is we try and abstract away a lot of that underlying infrastructure complexity that comes with machine learning development. So we go and we run on top of multiple different cloud providers. So we kind of have a managed Kubernetes service, so we go and we build out or deploy into your existing, on your existing cluster, whether that's in AWS, Azure, GCP, in an on-prem environment. And then you're able to go in and actually orchestrate these machine learning workloads against any one of these environments from a single pane of glass. And what we do is we handle a lot of that really, really hard stuff around container management, artifact tracking, intelligent job scheduling, and data orchestration, and really kind of all of the auto scaling of these nodes up and down depending on the type of workloads, making sure that you can bring all your framework, your tools, your code, that you're taking advantage of all of the latest drivers and hardware that you have available to you. And then all of that stuff is things that you don't really care about. You care more about kind of the business topology, where the data lives. I want to make sure that I can go in and run large scale distributed training there. I can go in and deploy my model that I trained in one cloud environment back to my on-prem or back to my edge locations. And you kind of have that end-to-end workflow where I have my workspace where I can go in and collaborate with other people. I can go in and iterate back my GPU inside the cloud containerized, and then I can seamlessly scale that out with these end-to-end pipelines, go and version track all of the different models and experiments that I'm performing, and then be able to go in and construct these very sophisticated pipelines, and then where I can go in and kind of programmatically choose the best model, go in and deploy that. And on top of all of that, Gradient has a kind of enterprise level management layer for access control, collaboration, visibility into who's running what workloads, kind of, and various resource controls that you have. A couple other like small semantics that are good to capture here is kind of you have the data governance, the data versioning to make sure that as you're launching many experiments, you're not pulling down the data many times, but you're able to still make sure that the same experiments that your machine learning experiments that you're performing are trained on the exact same data set that you kind of on when I go and I push new code, or kind of when the shape of the data has changed. These are kind of events that are might trigger me to kind of go in and retrain one of these pipelines. And then on the output side, you kind of need to make sure that you're going and tracking and capturing all of the artifacts of the system, the model artifacts, the TensorBoard checkpoint logs, and then kind of when I actually go in and where I deploy this, whether that's in one of the hyperscaling clouds, whether that's on the Paperspace GPU data center infrastructure, or whether that's into my on-prem or edge location, I should be able to seamlessly orchestrate these workloads and have my pipelines actually not be specific to a single cluster, but I can actually stitch them across multiple different clusters in a single kind of Git-driven defined pipeline. So that's kind of the high level slide deck of Gradient. Kind of, if there's any questions at the end, feel free to contact Misha or Daniel at Paperspace. Also want to just give a quick shout out that we have a free GPU plan on our data centers, where if you're going to want to go in and spin up GPU backed notebook, kind of very similar to Google Colab, but kind of has a lot of the things that we're going to be showing here today. Feel free to go and check that out. And so I'm going to go and start kind of giving you a high level overview and jump into the demo here, where we're going to be actually following the path of a typical machine learning or data scientist as they go and actually try and start up inside of a Jupyter notebook, go in and kind of perform your exploratory analysis, maybe make sure that the code is working, and then show how you go and can construct a very sophisticated end-to-end pipeline quite quickly, show kind of the lifecycle management inside Gradient as you go and kick off single node as well as distributed training runs, and I'll kind of talk a little bit about those, kind of show kind of how you capture the output models. You can go in and actually introspect what's inside of them, go and actually make these and serve real production traffic in a couple of clicks, and then actually kind of tie all of that back together to that Git-driven development workflow with Gradient CI, and show how quickly and how nice that is, and how that really can speed up the confidence at which you can iterate and really maximize your model velocity. So this is Gradient here. So this is kind of the console page that you go and you drop into. All of the capabilities in the platform are available via Web UI, SDK, and CLI. So depending on kind of the audience and the technical level, you can go in and automate things with the SDK and build pipelines with that, or you can kind of go in and use the Web UI to go around and navigate and identify these various parts. So as we go in and dive into kind of projects, there's a couple of different high-level entities that we're going to be using. You can kind of go and see them on the sidebar here. This is kind of the projects. You have notebooks, which is your GPU-backed workspace, kind of that cloud IDE. That can be VS Code or Jupyter, and you can go and run kind of Streamlit or any other kinds of applications inside there. You kind of have the jobs, which are that individual compute node execution that you get full lifecycle management of. You have kind of the data that you're going and pulling in, the various models that you have available to you inside of your team, and kind of their aggregated statistics, the experiment that produced them, the specific model files and aggregated stats there. You kind of have the deployments, which are those production serving endpoints. So here I kind of have one up that's been running for a little bit of time. I can go in and see it, kind of check out the GPU that it's running on, how many instances. So we kind of go in and auto scale and load balance and provide authentication. So all of these things that are very hard for you that are actually barriers to getting the end part of that pipeline really up and running, we try and make as simple as possible and have these very nice primitives for you. So what we're going to do today is we're actually going to start off with kind of walking through what the creation flow looks like. And this is the same for experiments, for notebooks, for deployments. So Gradient, kind of everything runs on Kubernetes, fully containerized. And so what that enables you to do is actually go in and as you go and launch any of these workloads, you go in and kind of choose the container that you want to go in and run it on. And this kind of makes sure that you're going to have that level of reproducibility. We try and make it as easy as possible, having a lot of the most popular packages and libraries already super available. So we're going to be using this TensorFlow 2.0 with Jupyter Lab notebook container. So this is going to go, and I'm going to go in and select this. I can also go in and, of course, choose and bring my own custom container, and we have container building inside the platform that's really easy to use. But kind of if to whatever level of kind of your technical skill set with going and tinkering with Docker files, all of that is kind of totally supported and is part of that dev workflow. But kind of we also go and try and just keep it as simple as possible and keep the cognitive overhead as low as it can be. And so once you've gone and picked a container, what you do is then you kind of choose the machine that you actually want to go in and execute against. And so this is some of like the machines that are available in kind of the SaaS platform today. These are some various GPU and CPU SKUs inside the Paperspace cloud. And then some of these are kind of the GCP machines. But inside this demo, we're actually going to be using, for this team, I kind of connected it to my private cluster. And so what private cluster means is kind of if I have my enterprise data, I want to make sure that I'm going and running my enterprise, like I want to run my compute where my data is. And so Gradient makes that extraordinarily easy to go in and configure a private cluster inside your like VPC environment, so the data never actually leaves that location. And I can actually go and super simply orchestrate workloads against that from within Gradient. So I'll go and select this machine. choose this private cluster, select one of these, let's say P2X Large, which is kind of the Tesla K80 GPU, or let's say I want to be playing around on a CPU machine here. I'm going to go and give this a name here, and then for like the machine intelligence, I can give like a walkthrough here, and then we can go in and kind of set something like auto shutdown, go click create notebook. So I've already booted one up, so I'm going to go in and open that up here. So this notebook I've kind of started up here, and what we're going to do is we're going to walk you through what kind of an end-to-end pipeline would look like using Gradient using the SDK. So for a little bit of context, we're going to be running kind of a variation of MNIST, which is kind of that intro level machine learning code, but we're going to be using it with a slight code change that enables it to kind of go in and scale out in a distributed fashion, which is something that you really need as you're going and tackling problems that aren't going to be able to complete on a single GPU, or the data set's not going to fit on a single machine. So we're kind of going to be able to take advantage of both data and model parallelism without needing to really make any significant code changes at all. And then Gradient allows us to go and execute against this and really scale up the number of workers and still see a really linear performance. So I can go in and get my machine learning insights in hours instead of weeks or months, or sometimes you wouldn't even be able to complete it at all. And so this is very standard kind of convolutions, not a very complex architecture here at all. But I want to just kind of level set that that's kind of the machine learning code that we're going to be using as we kind of go and do this walkthrough here. So as I go in and I kind of import, so I kind of have a notebook that I've already gone and set up here. So we're going to go in and start this up. Save this. So this is a Jupyter Lab IDE, by the way, for those who aren't familiar with that. That's kind of a variation of Jupyter that's really nice to go in and use. It has a lot of really nice primitives around kind of extensions and kind of better interface than other ones. This notebook also is kind of parameterized, so you can go and actually execute it end-to-end from the command line or as part of your machine learning pipeline. So inside the notebooks, you can actually go and construct really sophisticated pipelines using just code, using the SDK, and stitching them together and then tying that into Gradient CI itself. So I'm going to go in and run, instantiate the client here, which is kind of that Gradient package, and we're going to be able to programmatically interact with deployments, models, projects, clients. So this is kind of the building blocks of our machine learning pipeline. I'm going to instantiate this helper here, which kind of makes sure that we're not going to be reusing the same function name. And then I'm going to go in and kind of start off with running a single node experiment here. So I'm going to be using the set of hyperparameters for this training run. I'm going to be passing in the name of this experiment, the project that I'm working on. I'm going to be running this against the Paperspace, one of the Paperspace GPUs, kind of passing in a GitHub repository that we want to go in and pull down, tell it, hey, I want to be using this command on this GPU, and then I'm going to go in and actually execute that. And so I'm actually going to go in and quickly uncomment these two lines here, and then change this to actually be running against a P2X Large. So this is the first time I ran this, I ran it against the Paperspace infrastructure. And now with like a single line of code change, I'm going to pull it up right here, and we're going to see kind of that machine go and actually start up and start orchestrating. But I'm going to go in and run this one more time against a totally different cluster and show you kind of how that full lifecycle management happens. So here we're going. I just kicked off that experiment 20 seconds ago. It's totally up and running. We see kind of the type of machine that we're running on here. I can see kind of the full environment and how I could go in and recreate this experiment, the hyperparameters that we executed it with. And as we go in and we dive into the specific job itself, so this is kind of the worker that's correlated to this experiment. So we're only using a single node right now, and so it's just a one-to-one mapping, but we're getting real-time log streaming that we can both kind of get from inside the SDK and inside this notebook, and kind of inside the UI as well. And so we're also going to be going kind of getting those like system level metrics around the CPU, the GPU utilization, so we make sure that we're not going to be kind of getting bottlenecked and we're really taking advantage of the hardware to the fullest. And so these things have become super easy. We kind of see the code that we actually kind of went and pulled down and are executing with. Now, if we kind of take a step back here and go back into this project, we're going to see that we also kind of are going in and we're provisioning a different run here, which is against a totally different cluster than the one previously. So this is running against that P2X Large. So we see that really quick feedback loop, even in the research phase, when I'm taking kind of this code repo in this file here that we're using, and then going and launching it against a really powerful GPU, getting full lifecycle management, being able to introspect that run, and it's not running locally on my machine. It's kind of, I'm developing it in a cloud IDE and orchestrating against Gradient, which is a serverless machine learning platform. And so kind of experiments are one of the core training building blocks that we want to go in and use. And so I can go in and kind of, while this thing goes in provisions, I can go in and kind of add that to a specific TensorBoard instance, for example. So I can go in and add that to here. And so as it's outputting model checkpoints, I'm going to be able to go in and actually view and compare this experiment to other previous runs of the experiment that I'm using. So right from the get-go, I'm able to take advantage of powerful GPU hardware. I'm able to go in and actually compare these experiments against other experiments that I'm running and getting real-time feedback, because Gradient goes and brings in a kind of distributed storage layer as part of the deployment. So you kind of have really performant IO that's kind of shared across the different jobs and experiments inside your project. And you can see that inside the notebook ID here under /storage. That's kind of all of these TensorBoards and various projects that I have here. The one that I wanted to highlight is kind of this data element. So this is kind of the various COCO train test validation 2017 set, which is a common data set for kind of various object or image localization tasks. And we're actually going to be taking advantage of that as we kind of move a little bit later on. And it's going to allow us to really make sure we get a much faster startup time. So that was a single node experiment. Let's imagine that we want to kick off a couple of experiments, right? You're not always going to get the best results from one. A lot of the best techniques involve requiring you to go in and run many different hyperparameter combinations to kind of really scale it out. And so what we're going to be doing is we're going to be kind of running a MPI multi-node training run. So what the difference between kind of this type of experiment and the previous one, most of the raw building blocks are all the same. Kind of what project am I running it on? What are my containers? What types of machine do I want to use it on? But here, all we're now kind of splitting it out into, hey, this is what the master is doing. This is what the worker is doing. And what Gradient really does is, without needing to change much, we're doing a lot of the scaling up of these GPUs, making sure that they have the right drivers, dependencies, and then also kind of automatically setting up the networking and having the master go in and SSH into all of the workers to make sure that you're getting a really performant MPI run that is not something that you have to go in and deal with. Kind of, you're not needing to spin up VMs, SSH into, make sure that all of the appropriate ports are open, and then go and actually run your command. We're actually doing all of that for you. And when this experiment completes, we go and we totally tear down and clean up the network after it happens. And we do a similar type of thing for gRPC-based workloads too, which is what you need for TensorFlow distributed, where we kind of automatically set up the TF config in the background, so you can just one function call, which is, hey, get my TF config from the environment. All of a sudden, my parameter servers and my workers are capable of communicating and scaling up in a very effective fashion. And so here we're going to be running it all on GPUs, both master and worker. With MPI, the master SSHs into all of the workers who are sleeping and uses the kind of the generated host file that we provide to kind of know which workers are the right ones to do. And then all we're doing is we're kind of running an OpenMPI command before actually going and executing that Python file that I was showing you before. And so kind of this is inside source control already, so I'm just going to be able to reference that. But this workspace could be an S3 repo, it could be a Git, it could be a private Git repository, it could be a local file that you choose to go in and upload. So kind of depending on what feels natural for you with your development workflow, you're able to do that. And all we're really changing here is that cluster ID parameter. And I'm going to go in and so I have a couple other helper functions here around kind of going and looking through all the states, making sure that the logs are updating, then I'm streaming them in through the SDK and inside this notebook. But I'm going to go in and kind of run this multi-node MPI training experiment. So I'm going to go in and kind of scale that up to 2 different workers, each running on a GPU, and then 1 master on the GPU as well. So now all of a sudden, we went from running single node to being able to run really sophisticated, powerful things that scale up linearly up to hundreds of GPUs without seeing a significant drop off in performance. And that's really a massively empowering thing to be able to quickly go in and introduce into your pipelines these building blocks, which can really do a lot. And so this is kind of an MPI job. I had kicked off a couple of them previously. I'm going to go in and actually take a look at that. One of the ones that we had ran previously. And what that's going to, here, let me pull up one of these. Cool. So inside this gradient walkthrough project, I had kicked off a couple of experiments before this. So one of these that finished earlier this morning was this MPI run with 3 different nodes. We can kind of go and take a look at the master, see that, okay, I went and I did all of this SSH magic. I went and I kind of am doing my training, blasting through all the epochs because I'm using 3 GPUs really performantly, kind of splitting up the workload across all of them. I produced a model. And so this kind of, I can go in and I can see the specific model files that I produced, kind of the PB, the various checkpoints that I produced with that MNIST or that Harvard MNIST example. And then I can go in and quickly take that model and actually go in and deploy that as an endpoint. Or maybe I can go in and take a look and compare these different ones. Maybe I want to go in and check the tensor board, see that multi-node example. Maybe I want to filter out the single node runs and just kind of take a look at what is this multi-node run doing? How is the batch loss doing over time relative to the various, I don't know, epochs that I'm performing or kind of relative to the training time. And we see that it's doing pretty well. This model maybe kind of validates the checks that I want. Again, this is still very manual at this point. I'm kind of doing it, maybe I'm inside the notebook going to be programmatically choosing the best model that I produce. I can kind of go in and grab, hey, I kicked off 3 different experiments. Let me go and grab the best one based on one of these criteria, go in and choose it for deployment. And when we go and we deploy models, this is kind of the SDK syntax for doing that. I just specify, want to be using this image. It is kind of, I want for it to be running on this type of machine with being able to scale up to this many different number of instances, which is really important for having that load balancing, auto scaling authentication. So these primitives are the core elements of your machine learning pipeline. And here we're stitching them together in a single notebook. Right after this, we're going to go in and take a quick pivot to that source control development workflow. And instead of individually launching all of these, we're going to actually just push a commit and see how we're going to go in and launch these 2 new machine learning experiments and how that's going and how I can see that inside Git. And so this kind of deployment here that I went and kicked off, we see kind of it has an endpoint. I'm just going to go in and quickly show you guys that how you're able to go in and quickly perform inference against that, get the resulting probabilities. Very important to actually unlock values. So this could be returning image predictions. It could be going and doing BERT text translation. The domain doesn't really matter. The key is really that it's super, super easy for me to go in and trace back. Look, this deployment was trained on this model. Here's all the various metadata, model files automatically tracked for me. It was produced by this experiment, which I ran 9 hours ago. I can see exactly how I ran it, and I can go in and quickly reproduce that. And so this experiment actually that produced this model is one that was generated from source control. So it sees, hey, I'm Misha, I'm the author of all of this stuff. Here's the specific commit URL that's associated with that. If we kind of take another step back here and just look at the project in general, we'll see kind of, look, these are all the kind of experiments that I have running. I'm able to go in and manage these from the UI. Maybe I want to go in and stop this. And then I kind of go in and will automatically handle the spinning down of those GPUs that are available there. If we kind of scroll down a little bit farther down, we'll see that here I was actually developing these models with source control, which means that I have kind of commits that are associated with the changes that I'm doing. And so I can go in and click into that. And so inside this repository, here I can see kind of, look, I was making changes to this config.yaml file. So let's take a quick look into what my source control repo that I went and connected when I created my project was. And that flow is really, really easy. I know I didn't show that, but maybe I should. It's when you're going and creating a project in the first place, you can go in and kind of create a gradient CI project. And what that does is that actually forces you to connect your specific repository, install this gradient CI application. And when you do that, it goes and it kind of automatically connects to your Paperspace team and account, assuming kind of all of the credentials there line up. And it enables you to kind of not need to specify the workspace or the project ID. Those things are automatically passed forward. And so you have this PS project folder, and inside here I have a config.yaml where I have a couple of different machine learning steps. Here I'm running a single node experiment, and here I'm running this multi-node experiment where I kind of specify the kind of steps that I want to run, and each one can be one of these arbitrarily complex either notebooks or a distributed training run or a deployment, and I can choose the triggers on when I want for this to go in and execute. And so inside that project configuration, I'm kind of running this on the master, on like the default workspace, or when I go in and I open up a pull request. And I have these checks for, hey, when should this pull request actually go and get approved? And so there's a lot more on our doc site here. So if you ever want to kind of go in and read more, there's a ton of information here about Gradient and kind of all the different things and how to run the various elements that I'm showing. So kind of here I'm talking about Gradient CI and configuring that and what the various project and branch level ways of actually developing that workflow is. But kind of words speak a lot, but actions are much better. So let's go and actually do that. So here I'm inside my source control, or here I'm in my local VS Code environment, for example, and I'm inside that project. Here's this config.yaml that we were saying. So maybe let's say what I want to do is I actually want to run multiple workflows from the same pipeline. So here I'm running something which is called, I just called a param file experiment. So I'm specifying that same type of structure that we passed forward with the SDK inside my Git repo itself. And here I'm doing a similar thing. But here what I'm actually doing is I'm actually passing in a bunch of different data sets. So this will actually, and I'm passing in this E tag for each of the different data sets that I want to pull down. So like you can go in and specify any like S3 style bucket. And when I go and actually launch this workload, it's going to check, hey, have we already pulled this exact version of these files? If so, we don't need to do it. We're going to go in and mount that in under this particular name in my training code. So I can go in and get that data reusability and get that data versioning as part of it, not just the hyperparameters and container, but also capture the data that I trained on. And so I'm going to be using the GitHub desktop app. Dan always gives me a hard time about this, but I'm going to go in and I'm going to commit these two files here. Kind of I changed the epochs to be a little bit and uncommented this one. And so I'm going to go in and commit this to master. I'm pushing this up to origin, and then I'm going to go in and open up and see from Git the type of interaction that we're going and getting as we go in and train this. So I just pushed this up, and in a quick second, Gradient CI is going to pick up that commit happened and go in and actually orchestrate these machine learning workloads against Gradient. So here, if we look at this question mark here, we see, hey, look, there is this pending training run that's occurring here. We can go in and click details, and we'll actually see that this exact experiment is now being scheduled and provisioned and spun up, and the commit won't kind of pass that official build process unless the experiment completes successfully, and if it goes and actually follows any of those specific criteria that we went and set up. And so now all of a sudden I have this like really supercharged development workflow where I'm able to go in and kind of play around inside this notebook, make sure that the code is going in and running, that maybe I want to go in and kind of open up a new terminal, and then I want to do some kind of like gradient tensor boards list, right? Let's say I want to see the different tensor boards that I have available inside my team. Maybe this is the one that I was going and using here, this TB example. Let's say this new experiment that we went and just booted up, I want to go in and add that to that same exact tensor board as well. And so look, this experiment, kind of we went and started it up. I want to go in and add that here. And so now all of a sudden we're going to get this machine learning experiment, which is again doing really complex, sophisticated stuff. I'm doing distributed training with MPI on data set that's been cached, running on GPUs that are sitting in a totally different cloud environment than maybe the one that I had ran a previous step of the pipeline on. And I can go in and introspect this as it's occurring in real time. And that's a really powerful development workflow that really is very empowering for how fast you can go in and develop and iterate on these machine learning solutions. And so I've been talking a little bit about the end-to-end development, like these machine learning pipelines and ML ops and how these things tie together. And the answer is that like inside a notebook, I can go in and make sure all my code runs. I can validate everything. I can go in and actually do things like train many experiments, add them all into a specific tensor board, go in and compare those experiments against each other. And so in here, look, now all of a sudden we're seeing there's another experiment that's kind of aligned here. This is I was training a very similar type of problem, but you can go in and kind of see that I can overlay these two experiments, a single node, a multi-node distributed example, and I can in real time while this is updating, go and get that feedback because TensorBoard is pointing in at that distributed file system that we have. And so all these elements are really tied and integrated together. So if we go back into that Git repo here and refresh this, let's go take a look at that last commit and see how we're doing. So here are those two steps of the pipeline. This is the commit that I went in uncommented. It's kind of going in and pending, and this one is also. So we have two machine learning experiments that we kicked off from pushing code to Git. And these are kind of going and doing just a single training step. Maybe I want to go in and add a new one that's like, all right, once those are done, I actually want to open up a pull request. And if the model is better than what we have in production today, I want to actually go and deploy and update that deployment for us. So if we go and kind of, so we're seeing that this is that single node, this is this distributed MPI example. You can also do gRPC as well. It kind of kicked off by gradient CI. It's tied to a specific commit, so I can easily see who's the committer. I can go in and kind of look at it in GitHub, and so I can go back and look at something that I trained weeks ago and easily be able to fork that, make a new branch, open up a pull request, and be able to kind of iterate and make progress from where I was before. Now, if we take a look at, like, for example, this model here that we made, that we trained from CI, it produced this model that is version. We already have a deployment that's going and running. Maybe I want to kind of go in and actually make another deployment, but this time I don't want to deploy it to the, like, maybe I want to deploy it to a totally different data center. So I can train in one location, compile that model, and then make it run somewhere totally different. So we can go in and run this, let's say, I want to run on AWS and I want it to run on a totally different on-prem environment. So if we had a different private cluster connected to this team, I could go in and select that here. And then I could go in and choose, let's say, a K80 machine on GCP. And I want to say deployment number 2. And I want for this to go and have 2 nodes. And then I can go in and just start that up, or I can go in with inside my pipeline itself, go in and construct that component and choose, okay, I want to run this here. I want to run it on this specific cluster, and then I'm deploying the best model. And then as you make sure that this works, you can then go in and easily port that over into your source control repo, which is really kind of around a single machine learning project where you can have, this is kind of a business vertical that you have that is a production model. You have all of the code that backs it, all the model artifacts, and you can go in and orchestrate them. One last part that I wanted to really touch on is that we aren't restricting you to any specific element of the platform. You can kind of use one or all of the different components. Some people use this just for inference. You can, for example, go in and upload your own model. So you can bring in your own Onyx or Pickle or PV file, kind of choose the various model type that you want it, like Onyx, TensorFlow, just maybe custom model. You want to just go and deploy a Flask web app, choose a like walkthrough model, maybe give it like a model summary that you want to use, give it some notes, and then I want to be able to go in and just upload that directly. And what that allows me to do is kind of take a model I trained somewhere else. Maybe that's a pre-trained model. Maybe that's a model that's coming in from one of my other machine learning tools I'm using today that's not really allowing me to iterate as fast as I would like to and really build powerful solutions quickly. And then you can go upload that and then deploy it. Maybe I'm just trying to use kind of the experimentation, distributed training building block. Maybe I really just want the gradient CI into it, or just kind of the notebook GPU-backed workspace IDE, which is where a lot of people start off. But the thing that we really try and make sure is that even if you're starting off in a notebook, what you're able to do is you're able to think of how would I be taking this notebook and actually building a real powerful production grade pipeline where I'm doing distributed training and hyperparameter searches and getting that full end-to-end machine learning lifecycle and version management built in I'm able to get the models and then go in and deploy them at the end of the day. So that was kind of the demo that I wanted to showcase. Kind of talk a little bit about the data sets as well. We can go in and I don't think I actually showed that element of it. So let me make sure I do that. So for this MPI experiment that we ran here, inside the environment, we go and we'd actually see the various data sets that we want to go in and run. So that has the 4 different, what's it called? The 4 different elements of the Cocoa train test validation set. And so here we're kind of showing, look, this is where we're going to be pulling them in from. Once I pass that in, anybody can clone this specific experiment, make some changes to the raw code on how this is processed. But then all of these 4 data sets are being tracked, they're being reused, so you're not pulling down data many times. You're able to start up your experiments instantaneously. I'm able to orchestrate this against, maybe I want to run it against on-prem or on the public cloud or on Azure or GCP. So basically, we're super flexible to the infrastructure. We just try and allow you to not have to deal with the infrastructure and can really focus on scaling up how productive you are at solving your business problems. So with that, I'm going to kind of hand it back over to Johnny or Daniel. Again, if you have any questions about any of the stuff that we showed you in the demo today, feel free to contact us at Misha at Paperspace or Daniel at Paperspace. More than happy to chat and hear your questions or follow-ups. Yeah, thank you a lot.
Cool. Thanks so much, Misha. Dan, do you have anything to add before we wrap up this session?
No, yeah, just to reiterate, the ability just to really quickly sign up and test this product out. We do have this free plan that we introduced about 6 months ago, and so we're obviously very focused on simplicity and getting started in Jupyter Notebook can take under a minute. So just wanted to mention that again, and yeah, definitely happy to answer any questions via email or do a quick Q&A now.
Cool. Since we have some time, feel free to type your questions in the question window of GoToWebinar control panel, and we'll try to answer them.
Yeah, maybe one last thing that's kind of is useful to kind of go in and call out is we kind of have that community paperspace where we go and we share like common projects that are kind of just pre-built notebooks. And so what that lets you do is it lets you kind of go in and actually fork somebody's notebook. So let's say Dan comes into this team, he wants to kind of continue from where I left off, but he wants to capture the packages, the code, etc. that I'm running. He can go in and I can go in and kind of share this and kind of pull it up inside that walkthrough interface. Kind of it'll go and create a static file so I can go in and see what's going on, or I can go in and actually fork one of these containers that somebody else had previously been running. And what that allows me to do is kind of copy the container, the environment that they're using, and be able to kind of go in and exactly continue. So this is Dan's test notebook, but here I'm going to change it to Misha fork of Dan's notebook. And so now all of a sudden we're actually collaborating on the raw underlying Docker container with the code, with the kind of machine learning work that he's doing. And so Dan can go in and fork this walkthrough notebook and very quickly be able to pick up exactly where I left off beforehand, which is really powerful. So not only can you collaborate at the notebook level, but also at that project and experiment and code level too. So just that level.
Oh, sorry, didn't mean to cut you off, Misha.
Last part I realized I forgot to cover.
Definitely, yeah, and just wanted to mention that we also have, if you want to pull up on your screen the ML showcase really quickly, just to kind of show how you can fork some pre-made projects. This is a sort of a curated collection of various projects that we have developed that are sort of one click, where we have all the various pieces put together for you, so you can just run through a quick example. These are all Jupyter notebooks. So there's some really cool examples here that you can kind of play around with and fork for free. And the last piece there is you can actually share these publicly. So if you wanted to, work with or make some of the work that you're doing public, you can just hit that share button in the top right, and anyone can access the notebook that you're working on.
Awesome.
Thank you so much. Thanks again, Johnny, for having us here.
Cool. So let me become the presenter. Give me a second. I will. Great. So Daniel and Misha, thanks so much for joining me today, for walking us through the Gradient ML PaaS. So before we wrap up, I just want to share my comments. I have had some experience working with Gradient, and one of the key takeaways for me is the ability to run machine learning platform as a service across multiple cloud platforms or in a hybrid scenario. Today, there are multiple PaaS offerings in the market, but where Gradient really stands out is the ability to run that on any infrastructure, including Paperspace's own a set of VMs, or as Misha has shown, it could be on AWS, it could be on GCP, or even in a data center within an enterprise. You can pretty much run this as the ML platform as a service. And the tight integration with Gradient CI with GitHub, and the ability to create end-to-end pipelines is another unique capability of Gradient. So this holds a lot of potential, and I definitely think this is going to stand out as a very unique cloud agnostic, infrastructure agnostic machine learning platform that delivers enterprise capabilities. So with that, we wrap up today's session, and I am pretty excited to announce the next session on Feb 6th, where I'm going to talk to you about running stateful workloads on Kubernetes in production. Kubernetes is typically used for running stateless workloads, but as the adoption increases, a lot of customers are moving traditional stateful applications to Kubernetes. So joining me this webinar would be P2X, one of the Bay Area companies, which also happens to be one of my sponsors. And between P2X presenter and me, we are going to walk you through an end-to-end demo of deploying a highly available stateful application and going live in production environment on Kubernetes. So that's on February 6th at 8 a.m. PT, 9:30 p.m. IST. In a few minutes, this link should become available. In fact, it is already available. You can go to mi2.live and sign up. So that brings us to the end of this session. I again want to thank Dan and Misha for joining me today and contributing to the machine intelligence track of MI2. So in a day or two, I'm going to upload this entire recording to the YouTube channel, and you would receive a follow-up email with the link to the video. And you should definitely check out the documentation of Gradient. It is very valuable. It actually teaches you a lot of fundamental concepts of machine learning and deep learning. I'll also include that link in my YouTube video. Thanks again, and I'm looking forward to seeing you in the next webinar on Feb 6th.